Okay. Now, do you remember when I used to write this equation? Let's say the equation was y equal to a cos kx minus omega t. If I have this equation, then what does this y used to represent? Do you remember? What does this y used to represent? Displacement of a particle for a fixed t and fixed x. Na? So this used to represent displacement. So hopefully you are writing with me, of particle at fixed t, fixed x and t. Yes? But this used to represent something else as well. What can we find it more? What does this y represent more? It also describes the wave, na? The wave that passes through the medium. It also describes that. So describes the wave. Yes or no? Yes? And then we used to say, just by tracking the motion of the particles, if you know how the particles will move as a function of x and time, you can actually describe how the wave will move. So the physical quantity that we were concerned with was displacement. Displacement. Also, when I used to make this picture, then it's a cosine wave. Acha, let me, before even that, what kind of wave it is? What's so different or what's so unique about this wave? Can somebody tell me that? What's so unique about this? Anything else? It's a harmonic wave. And what do you mean by a harmonic wave? Who performs SHM? The wave performs. The particles of the medium perform SHM. Na? And so if you remember, in general, when we started with the wave motion and everything, then I said any function that can be written as any function which is a function of x and t, and that actually obeys an equation. What was the equation that it had to obey? The wave equation. And what was the wave equation given us? I think del 2y by del t2, and then v square upar tha ya niche tha? Upar. So there's a v square del 2y by del x2. है ना? Any function which obeys this equation is a valid wave function. Yes or no? And then the particles that if the wave passes through the medium, then the particle oscillates. Okay? In general, it oscillates. But if you take this specific form of this function, then the particle performs SHM. है ना? Please understand this, that SHM is also a form of oscillation, but it's a unique form. What's so unique about SHM? What is so unique about SHM?
Forces directly proportional to displacement.
Displacement only. The force is directly proportional to negative of displacement. And what does it mean? That there is a restoring force. Every time a particle tries to move away, it ends up getting back. है ना? So every time the particle will come back to its mean position. This is SHM. What was the condition? That A is minus proportional by. You should know this stuff. है ना? So that's the difference between any kind of oscillation and SHM. Okay. So you have a harmonic wave, and earlier when we used to talk about wave motion, we used to make this diagram. है ना? चलो ये सब छोड़ो अभी. I have this harmonic wave y, x, let me fix t. If I fix t, then it's a cosine graph, na? And how will the cosine graph look like? ऐसा कुछ? Yes? And do you remember how we used to imagine how are the particles oscillating? They are oscillating like this. है ना? Earlier, in all of our discussions, my particles were oscillating like this, and whatever is their oscillation, that actually matches my wave, है ना? And as a function of time, they keep on increasing, decreasing, and that's how wave moves, है ना? And what is the direction of oscillation? Where is my wave moving, by the way? In the positive x direction. Where is my particle oscillation? Perpendicular to it. So what kind of wave? Longitudinal. Your particle is oscillating perpendicular to the wave motion. It's a transverse wave. I will obviously have the same equation again, but now you should modify the picture that you have in your head. You should not have this kind of picture in your head, because all of our discussions will be based on longitudinal wave. So how longitudinal wave particle oscillates like what? Parallel to the wave motion. So it should, तो ये अभी ये picture of the, modify the picture that's in your head. So it should be something like this. If I have this x, I will again have a representation like this, but how will my wave move? The actual particles, ये देखो ये जो particle है ना इधर, that will oscillate like this with a maximum oscillation. And what about the particle which is here? A little less oscillation. What about the particle here? Will it oscillate? No. What about the particle here? Now the direction has changed, so that means it's oscillating like this. Yes or no? And what about this particle? This oscillating like this. So modify the picture in your head now. These are not oscillating like this. These are oscillating like this, back and forth. Please remember this. Is it okay? Is it okay? Good. This cos graph is just a way to represent how my amplitude will vary, or how my particle is going to get displaced. That's just a function to pictorially represent us. What is the actual motion? These are the actual motions. Does it make sense to you, whatever I have said? Good. Now we have been talking about all of this, but we were tracking the displacement of a particle, and then we said if I know this physical quantity displacement, I will be able to describe my wave. But it need not be that only displacement can be used to describe a wave. I will introduce some other physical quantities which can be used. Okay, so let's do this. Let's do the relation. So hopefully everyone has written till here, so I'm going forward then. Relation between pressure wave and displacement wave. If at some point I'm going too fast, then please tell me, okay? And if you're not understanding anything, then please stop and tell me. Everything was okay up until here? The picture is okay? This is the picture that should come to your mind when we talk about longitudinal waves. Okay? Good. And why did I write all of this? Because I wanted to highlight that up until now, we were tracking the displacement of particle, and that was describing the wave. Now I will track some other physical quantity, and let's try to do that. Relation between pressure wave and displacement wave. Okay? Just for fun, can you tell me what is the definition of bulk modulus? What is the definition of bulk modulus? पढ़ा है ना elasticity? Anybody remembers? That's why you should revise. That's better, Young's modulus. Any kind of modulus of elasticity, that's Young's modulus and other things, bulk modulus, are just stress upon strain. But now which stress and which strain, that you have to think. Young's modulus means it's longitudinal stress by longitudinal strain. What about bulk modulus? It's volume stress by volume strain. If I have volume stress, stress is defined to be force upon area, but that's also pressure. So I can write it change in pressure by volume strain. That's change in volume divided by original volume. And there is a negative sign in front of it. Do you remember this? This can be written as minus V delta P by delta V. That's why you should revise. What is the delta V? That's the change in volume. Okay. Just for fun I wrote this. Let's try to see whether it will be useful to us or not. Now let's keep it aside, okay? Imagine that you have a medium, a gaseous medium, and you have not started any kind of sound wave through it, okay? It's just a medium. And I'm going to study a very, very small part of the medium, and let's take that part to be a cylinder, okay? If I take that part to be a cylinder, let's say it has a cross-sectional area S, and the cylinder is something like this, okay? Let's say this is x equal to 0, this position is x, this is delta x, that means this is x plus delta x. Okay? What is the volume of this cylinder? Volume of cylinder is what? S into delta x, na? Does it make sense? S into delta x. That will be the volume of the cylinder. Okay? I have not done anything. It's just a medium with a particle, a bunch of particles, and I am considering some volume. Now let's say if I put a speaker in front of it, and from speaker what will come? Sound waves that carry disturbances. And what will those disturbances do? They will oscillate the particle, na? Acha, remember this, even though the picture may look like different, but remember, always remember ki when a wave passes through a medium, the medium doesn't move with it. The wave moves through the medium, but the medium only oscillates about its mean position, it stays there. Okay? Remember that always. So when I have this situation where let's say I put a speaker in front of it, speaker rakh do. Okay? What will happen? Sound waves will come, na? As the sound waves will come, the particle which were here, they will oscillate, na? Oscillate in which direction? Aise? Then? Aise? Yes? They will oscillate like this. Along the wave motion, because it's longitudinal wave. Let's say they oscillate with a displacement of y. Okay? And the particles that were here, they need not be oscillating with the same displacement, na? In general, they can be oscillating with some other displacement. Then what is the displacement here? Let's say y plus delta y. Then what will happen is this cylinder, this cylindrical thing will get shifted. Can you see that it will happen? ये y and यहाँ से y plus delta y. And now please understand this. Don't come up to me and ask me, sir, when the sound wave went through the medium, then it actually moved the medium. No. It's just the particle got oscillated. We are looking at some instant of time. Afterward, it will come back. है ना? So on an average, it's not moving at all. Okay? So fixed time here. At some fixed time, I'm looking at the situation. Now understand this very carefully. If the particles here moved by 5 meters and the particles here also moved by 5 meters, then will there be any change in volume? What do you think? Will there be a change? No, because they move by the same distance, so it's basically as if that you shifted the cylinder. Na? What if you move by 5 meters and here you move by 8 meters? Then what will happen? It's as if that you have stretched the cylinder. Yes or no? And there will be some change in volume. What will the change in volume be equal to? What will be the change in volume equal to? Can somebody tell me that? सोचो. if you only move by y and you move by y, there is no change in volume. But now you have moved by some extra amount. And what is that extra amount? Delta y. Then what is the extra volume? No. S delta y. It should be S delta y. Can you understand why it's S delta y? How many of you understand that? S delta y hona chahiye. Should I say it once more? Let's say you had a cylinder here, you had a cylinder here, and this cylinder got shifted by 5 meter. This cylinder this end got shifted by 8 meter. So now your shifted position is here, and this is here. Hai na? So this is a little stretched. What was the initial? If it were to be only moved by 5 meter, then it would be here. Yes or no? Then what is the amount of increase in volume? How will that is 3 into S, and what is that here? Delta y into S. Does it make sense? Because we are talking about volume. Volume is area into length, na? Is it okay with everyone? So I am erasing this. Bolo.
We're just tracking the movement of the particle.
Yes, but actually in general we are tracking the movement of the cylinder, and that cylinder composed of many particles.
But cylinder is just the medium, right?
Yes, the cylinder is a part of a medium, a small part of the medium.
But we are basically tracking the sound wave that is coming and thereby moving a medium wherever.
They will disturb the medium. They will disturb the medium. That's why the particle got oscillated. That's why they moved. And they moved by some different amount. And we are talking about this cylinder. What will happen to this cylinder? It got stretched, or it may even got compressed. Depends on whether this increases or decreases. Does it make sense? ठीक है. So what is this? The initial volume. And what is this? The change in volume. Then I think I already have some things which can relate to bulk modulus. Huh? What was the definition of bulk modulus? Minus V by delta V into delta P. ऐसा कुछ था क्या? Please check. What is V then? S delta X. And what is delta V? Into delta P. Then I think I have a relation for delta P. And what is delta P equal to? Minus B delta Y by delta X. Okay. And if I take the cylinder to be very small, in the limit that delta X tends to 0, in the limit that delta X tends to 0, what will happen? Infinity. Arey bachche, I have told you this. What is the meaning of this? What is it equal to? Yes. No, not partial in general, but dy by dx. This is the definition. Na? तो मैंने जब differentiation I started, I told you this, right? But this is only true when y is a function of one variable. What if y is a function of 2-3 variables? Then what should I write appropriately?
Partial.
I should write partial. It's much better to write partial, because delta p will be equal to minus p del y by del x. And now I think I already have a harmonic wave ka equation. What was the equation? What was y? I assumed it to be a cos kx minus omega t, right? Then what is del y by del x? What is del y by del x? बताओ. करो, मन में करो. You don't have to write anything. What is it equal to? What is del y by del x? Hey, somebody tell me.
Minus a sin kx minus omega t into k.
Into k. So I should write minus a k sine kx minus omega t, na? Is it okay? then what is delta P? Minus B into minus AK sine then it should be something like this. Then I can write BAK sine kx minus omega t. And now look at this. What is this delta P represents, by the way? That's the variation of pressure in the medium. So it obviously makes sense that, I think you already have a little bit of sense of this, ki as a traveling wave, or rather no, as a transverse wave contains crest and trough, then a longitudinal wave contains compression and rare refractions, है ना? And compressions are basically the points at which the particles are moving towards each other. And what about rare refractions? Those are particles that are moving away from each other. That is the picture ना. मैं picture एक बार बना के दिखा देता हूँ, है ना? And as the wave moves through the medium, then obviously you will have regions of high pressure and regions of low pressure. So there will be a variation in pressure. Does it make sense or not? And just by looking at this variation in pressure, can you predict how the wave will move? You can predict, right? Before we were tracking the displacement of particle. Now we are tracking the pressure of the medium, how the pressure will vary. And as the pressure keeps on, it's a function of time as well. So this wave will keep on moving forward. And then you are basically describing the wave. Okay? So just by looking at the pressure variation, you can describe the wave. So I have another physical quantity now, which can help me to describe the wave as it passes through the medium. So let me write it. This is variation of pressure of medium, and this can be used to describe the wave. Does it make sense? Please, if you don't get it, then please ask. Is there any problem till this equation? Anybody who did not get it? I will scroll, I will wait. Okay. From where you want to write? From here? I will wait 3 minutes, then I will start with the theory. Bolo.
You go here V equal to S.
Safe, yeah.
So we again took the same change in the volume and again into S. Done like that.
Change in volume, nahi. This is length into area. Length into area is volume, na beta? Length of the cylinder times area. That's volume, na?
Volume of cylinder is 2 by 3 pi r square h.
अच्छा बेटे. Volume of cylinder he is saying is 2 pi r square h. ऐसा कुछ बोल रहे हो ना बेटा? 2 by 3 pi r square h. ये pi r square h में ये pi r square क्या है? ये क्रॉस सेक्शनल एरिया ऑफ अ सर्कल. ये सर्कल ही है ना? सर्कल का एरिया ना? Now what is that h? The length? वही है ना? ठीक है. Written till here? Please write fast. अच्छा, रफ बुक में? तो ये इतना खाली पेज क्यों? इतना क्लीनलीनेस. वेरी गुड. हाँ बेटा, सही पढ़ा रहा हूँ ना?
आगे क्या पढ़ा?
नहीं चेक कर रहे हैं कि सर सही पढ़ा रहे हैं या फिर निकालना चाहिए सर को. है? अरे अरे कोई बात नहीं. Understood?
Sir, here the movement of particles, I didn't get how the wave will move. Sir. I understood like when it's moving up and down, it's going like.
I will make some graphs now, and then you will understand. I'll make 4 graphs, तब समझेगा. समझ आ रहा है? Writing? ठीक है. लिखो बेटा. इधर बताओ. रिवाइज करके आए थे क्या? ठीक है. अच्छा ठीक है, बोलो. हाँ पूछो पूछो, क्या पूछना है? अच्छा ठीक है. समझा स्वानंद? Can I go forward? Is it done? So, what is this B by the way? That's bulk module. What is that A? Amplitude. I will not call it amplitude now. I will call it displacement amplitude, because there are 2 waves now, na, which describes my. And what is that K by the way? Good. So A is displacement amplitude. Remember that amplitude just represents the max value. Okay, max value of anything. So what is the max value of this delta P? What is the max value of that delta P? BAK. Yes or no? So I should write delta P max. This will be pressure amplitude, na? This will be called pressure amplitude. And that's equal to BAK. So there is a relation between pressure amplitude and displacement amplitude. This delta P max is BAK. Is it okay with everyone? Whatever is in front of a sine or cosine, that's the max value. Hopefully everyone knows this. Okay. Then let me make some graphs. Let's try to imagine what is happening here. This is x-axis, y. So x delta p. Later on I will also make x and p. ठीक है. First let's try to make this y and delta p. Actually, even before all of this, I should ask this. Let me write 2 equations and then you tell me what's the same thing and what's so different about the 2 equations. ठीक है. So y is equal to a cos kx minus omega t and delta p is equal to BAK sin kx minus omega t. I have these 2 equations. What is different between these 2 waves and what is same about these 2 waves? Tell me. Tell me if that is so, then what's the difference? What's the difference between these 2 waves? What is the thing that is same in these 2 waves? What is same? Go out. Go out, go out. Don't. Then go and sit at the back. You are saying something? Amplitude is same. Both are harmonic. Can you be more precise?
The particles in both the waves perform as it.
What is same and different between these 2 waves? Think. Tell me more. More.
One is transversal and one is non-linear.
No, both of them. अरे idiot, वो नहीं है. It's so simple. They have the same k and same omega. That means the wavelength of the two waves are going to be same and the frequency of the two waves are going to be same. So simple. ये k1 k2 लिखा क्या मैंने इधर? It's same k, same wavelength, same frequency. What about the speed? What about speed? The speed is also same. That's omega by k and that is also same. What about amplitudes? Amplitudes are different or not? One of them is A, one of them is BAK. Could be this could be greater than A, this could be less than A. Depends on the K value entirely. What about the phase difference? Do they have a phase difference? They don't. Pi. Should be pi by 2. What is the phase difference between these two waves? Pi by 2. So they have the same k and omega. The amplitudes are different and the phase difference is pi by 2 radians. Yes or no? So इतना simple observation करना था. Anyways, so let me try to make this y versus x curve. It's a cosine wave. तो cosine wave कैसा दिखता है बताओ? ऐसा कुछ? So let me try to make it. This is my cosine wave. Now let's try to make my delta p versus x वाला graph. तो let's try to make it precisely. Okay. So delta p follows cosine or sine? That's a sine wave, so I should have something like this. तो pi by 2 का phase difference है क्या? देखो जरा. It's not so good, but make it better in your books. What is the amplitude here? What is this delta p value here? Can you tell me that? Delta p value here. BAK. Should be BAK. And what will be the delta p value here? That's minus BAK. What will be the y value here? That's plus A. What will be the y value here? Minus A. Can you see that they have the same wavelength, by the way? And okay. Let me talk about some more things. Let me try to make this P versus X graph. ठीक है? So ये P versus X graph है. And this is delta P versus delta X graph. अरे यार. This is A. This is delta P versus X graph. Now what is this P? The P represents the pressure of the medium after the wave has started moving through the medium. Okay. So let's say what is the delta P represents? That's a variation in pressure. Variation from what? Variation from the initial pressure. So delta P can be written as P final minus P initial. Does it make sense? Does it make sense? What is the initial pressure of the medium when nothing is moving through it, when nothing is disturbing it? What is the pressure of the medium when you don't? 1 atm, na? That's atmospheric pressure. So what will you get then? Let me call it P naught, and this P naught I will call it atmospheric pressure. Then the pressure finally is delta P plus P naught, na? And what is that PF? That is the pressure that you find at different points of the medium after you have started the sound wave. तो speaker कोई चालू कर दो कहीं पर, and now the medium got disturbed. Yes, and it got some variation in the pressure. And what is the variation? And the final pressure of the medium is given like that. Yes, so this is the pressure of medium after sound source. Does it make sense? Some kind of variation plus P naught. So what do you think my graph will look like then if I plot P versus X? And obviously please understand this, I am fixing time everywhere. So मैंने लिखा नहीं, but hopefully you know this. Fix T. Otherwise this wave will keep moving. We don't want it to move right now. I am fixing T everywhere. बताओ how will the graph will look like? You already have a delta P ka graph and now you are adding a constant to it. What will happen to the graph? Yes, it will get shifted, na? It will start from P naught. It will get shifted and I think the graph will just look like this. So ये मैं थोड़ा गंदा बना रहा हूँ, ऐसा कुछ होना चाहिए ना. ऐसा कुछ तो ठीक है. And from where are you starting? P equal to P naught. And if you were to make a P equal to P naught wali line, then with respect to P equal to P naught, this will be symmetric. But with respect to P equal to 0, it's asymmetric. And what is the max value of this? What is this P value? That will be minus BAK plus P naught. And what about the max value here? BAK plus P naught. Just add a constant. So BAK plus P naught. Are you okay with the graphs? Now try to actually imagine, these are just graphs for mathematical simplicity. But what is the actual picture? What is the actual way in which the wave is moving? Acha, here your variation in pressure, or rather here, the pressure of the medium is maximum. Na? Where do you think the pressure of the medium will be maximum? Where do you think will the pressure be maximum?
The closest to the source of sound.
At points of compression. At points of compression, the particles are going towards each other. Then you will have maximum pressure here. And what about those points at which you are finding minimum pressure? What will you get there? Rare refractions. So what should the picture look like? The picture will look like this. Here and here and here again and here, something like this. As the wave moves, this also moves. So pressure variation, I am fixing time again. If I don't fix time, then what will happen? Moves. Yes or no? So this is, and what are these happening? ये हो क्या रहा है by the way? Either particles are actually oscillating towards each other. And what about here? The particles are oscillating away from each other. Do you understand? Make the diagrams, and when you are done, then tell me. Is it visible to people in the back, or should I maximize a little bit? Visible है? दिख रहा है? बोलो.
Both of them are the same years.
Last two? Second or third, or?
Second or third.
Second or third are not same. One of them is a variation in pressure, the other is the final pressure. There is a change in pressure in the medium because you have started on the source of the sound, and the source of sound basically brings a disturbance in the medium. and that disturbances causes pressure का variation, है ना? करो. Once you are done, then tell me. So if you look at it, just by looking at the pressure variation or the final pressure ka graph, you can predict how the wave will move, na? So the pressure variation or the pressure wave also describes my sound wave. So we found another physical quantity which can be used to describe the sound wave. Earlier we used to do it by displacement. Now we are doing by pressure. Can you, just for fun, can you tell me can you anticipate what should be another physical quantity which will help me to describe the sound wave? Density, yes. ये तो देख के बोल रहा है ये book में से. लेकिन you do understand that density will also vary, na? As a particle gets accumulated at one point, the density increases, and when they move away from one point, the density decreases. And thus you have a density variation as well. And if you study that density variation, you are basically studying the wave. ठीक है? हाँ, और देख लो बेटा बुक से. वो चेक कर रहा है कि सर सही पढ़ाते कि नहीं. अच्छा. हाँ, जानता हूँ मैं बेटा.
Sir, I kept it previous but then I opened it for the previous chapter, but then I came to...
हाँ, it's okay. बेचारा कितना जस्टिफाई करता है खुद को. Is it done? बोलो. Basically your sound, अच्छा, switching on source of source. वाह. This is sound. बोलते रहता हूँ, लिखते रहता हूँ, मुझे कुछ समझ नहीं आता क्या लिख रहा हूँ. But is it okay? If you are done with it, then please tell me. Are you understanding? Not saying anything. और नीट की प्रिपरेशन कैसे चल रही है? अच्छा, नीट छोड़ दिया. नीट एडवांस करो बेटा. नीट एडवांस इज अ न्यू एग्जाम. इसमें एडवांस कॉपी होती है. इज इट डन? तो can I go forward? Great. So we can already anticipate that another physical quantity that will help us is density, na? So let's try to relate it. So density करते. Am I going too slow? अच्छा. Yes, am I going too slow? Should I increase my speed? At this speed we will complete our syllabus in 5 years, and after that you can opt for BCom. Hi, Indivar. बीकॉम करोगे कि नहीं? क्यों? अच्छी चीज़ है। कितनी नींद आई? कितना सो लिया?
अब जाते हैं।
अच्छा, अब जागोगे? अच्छा अच्छा, नींद ही नहीं आई?
हाँ अभी है।
ओके ओके। क्या है इसके बाद में? कैन आई गो फॉरवर्ड? चलो चलो, जल्दी जल्दी हाथ चलाओ। बोलो बोलो, क्या है? हाँ टेल मी, क्या है? तो हंस क्यों रहा है इडियट?
He said, can I go forward? You were going back.
कैन आई गो फॉरवर्ड विद द सिलेबस? हाँ,
You're going.
आई एम गोइंग स्लो। ठीक है, कोई बात नहीं। यू कैन पुट योर बुक एंड द पिलो टुगेदर एंड देन वेक अप टुगेदर, वेक अप विद द होल सिलेबस इन योर हेड। ठीक है, इज इट डन? ठीक है, तो रिलेशन बिटवीन डेंसिटी वेव एंड प्रेशर वेव। ओके ओके, बढ़िया बढ़िया बच्चे मिलते हैं। What was the definition of bulk modulus? Minus delta P by, this is the definition ना, stress divided by strain, volume stress divided volume। हाँ, तो minus V delta P by delta V. अब we will try to relate this volume with density। So what is the relation between them? What is density equal to? Mass divided by volume, and this will be mass upon this. So I will do this, I will write this delta, but keep it in mind कि it's basically differentiation, it's d. So if I write del rho or delta rho by delta V, what is this equal to? What is the derivative of 1 over x? Minus 1 by x square. So I can write it like minus m by v square. Yes, now I want some, I want this, right? V by delta v. So I can write it like v, let's put one of the v here, by delta v, and this will be minus m by v in 1 by rho delta rho. Please check my steps. And what is m by v equal to? That's density, na? So I can write it to be v by delta v is minus rho by delta rho. Is it okay? Then what will I get then? Then I am getting b is equal to minus, and there is a negative again, and this will be delta rho is rho by b delta p. And now I already have an equation for delta p. What was the equation of delta p? We found it just now, na? BAK sin kx minus omega t, na? So I can substitute and I will get delta rho as rho by b BAK sin kx minus omega t. And what will you get then? Is it okay? Please check. Rho ak sine kx minus omega t. Okay. What is the max value of this wave? So this is, what is this delta rho, by the way? The variation in density of the medium. So as the disturbance moves through the medium, the density keeps varying, as a function of x and t. The variation of density of medium. Okay. What is that rho? What is the rho? That's the density of the medium. Initially, when no disturbance was moving, what was the density initially? So this is the density of medium, na? Is it okay? Can you tell me the max value of this wave? That's rho ak. So delta rho max that's rho ak. Do you remember what was delta p max? What was delta p max? That was b ak. So can I find some kind of relation between delta rho max and delta p max? How to find? Just divide the equations, huh? And I will get the relation. What is the relation then? Delta rho max divided by delta p max is equal to, I think, rho by b aa raha hai kya? Is it okay? We have this equation. This is the relation between, so I have a relation between displacement amplitude and density amplitude. So this is called density amplitude. And now I have a relation between density amplitude and pressure amplitude. ठीक है? Now let me ask you this, and let's check how much do you revise. What is the velocity of a longitudinal wave in a fluid? I have written expressions for you when I was talking about wave motion. No. Mu into root t by v. कुछ भी बोलता है. Let me ask the question again. Velocity of a longitudinal wave in a fluid. If you don't remember, तो पेज पलटाओ. पलटाओ जल्दी जल्दी देखो. That is the velocity of a wave on a string.
Root gamma by rho.
Gamma by rho. एक था gamma p by rho. But gamma p by rho भी नहीं बोल रहा हूँ मैं, ओरिजिनल फॉर्म बोल रहा हूँ. I have also given you what is the velocity of a longitudinal wave in a solid. I think that was under root y by rho. तो यंग्स मॉड्यूलस इधर यूज करते हैं. तो फ्लूइड्स में क्या यूज करते हैं बताओ? बी बाई रो, बल्क मॉड्यूलस यूज करते हैं. तो इतना मैंने हिंट दिया, तब जाके बच्चों ने बोला. तो रिवाइज करो, रिवाइज. velocity of longitudinal wave in fluids is equal to root v by rho. That's v. If I take the square and reciprocal, then what will I get? Rho by v is equal to 1 by v square. Please check. सही है क्या? Is it okay? I took the square and then I took the reciprocal. तो rho by v इधर भी दिख रहा है ना? Then what is my delta rho max related as? That's 1 over v square delta p max. Another relation that you should know. What is that v? That's the velocity of the longitudinal wave. Is it okay? Is it okay till here? Am I going too fast or am I going too slow? अच्छा, no opinions. हाँ नागा बताओ. षणमुख स्लो. अरे ठीक है. I am repeating it again. If at some point if you find ki I am going too fast, then tell me to slow it down. And can you now already guess ki this variation in density also tells me how the wave will move? Because if you try to make this wave, acha, let me also ask you this, ki I have this delta rho as rho ak sine kx minus omega t. I have this delta p as bak cos kx minus omega t, and I have y is equal to a cos, this is also sine kx minus omega t. Can you now tell me what's different in delta rho and delta p and what's same? They have k and omega to be same. What is different? Their amplitudes are different. Anything else that is same? Do they have a phase difference? They have zero phase difference. They are in phase. They are in phase. So you should know this stuff. Acha, obviously as the regions of compression, you will have particles which are moving towards that region, so you will have a density more, and particles away from moving from some point, that will be density less. And just by tracking this density variation, we actually can tell ki where is my wave compressing and where is it ray refracting, है ना? And as you let the time move, then the wave moves and the variation also moves. So if you track the variation of density, you are tracking the wave. Does it make sense to you? Should I repeat once? See, regions where the density is more, there will be rare compressions. Regions where the density is less, there will be rare refractions. है ना? As a time, if you let the time move, that means as the time moves, this wave will move. है ना? Wave starts moving. I am fixing time here. Now I am letting the wave move. तो ये variation in density भी move होगा. तो अब ये इसका picture at some other time देखोगे, तो ये move होके इधर आ गया, और ये इधर move होके इधर आ गया, फिर इधर एक ray refraction हो गया. तो as you let the time move, their variation will also keep on changing, na? Because also, obviously variation is also a function of time. Does it make sense? You track the variation of density, you say somewhere somewhere it's more dense, somewhere it's less dense. You are basically tracking the sound wave. Is it okay? Good. So yes, it was the first lecture, and that's why it was very, very theory heavy. But can I start with some problems then? हाँ? ये कुछ बोलोगे कोई इतना? Good. So I'll start with some problems, and some of the lectures will be problem heavy as well, but not in the starting 2-3 lectures. I'll try to introduce all the theory altogether. ठीक है? तो पहले ये, let's do this very simple question. कि you have written till there, na? Everyone has written? Great. So question अब मेरे टैब में है और टैब मेरे पास है नहीं, तो the pressure wave in a medium is given as delta P as 12 sine 8.18 x minus 2700 t plus pi by 4 Newton per meter square. This is the wave given to be, and now they are asking to find, given density of air to be 1.29 kilogram per meter cube. This is given. Then find displacement amplitude. You have to find this. Okay? Attempt. I am giving you 4 minutes to think, and then I will start. When you do come in the next lecture, please revise this chapter, the whole thing, also wave motion, and then come. I'll start at 104. Just go with the basics. Don't try to overcomplicate. Whatever formulas I have provided, just try to apply them. Anybody with any answers? How should I approach the question? Can somebody tell me that? How to solve it? It's a single formula question, by the way. Give me the book. Should I start? Should I start or are you attempting? Okay. Okay, I will wait 2 more minutes and then I will start. It's 106. Hmm.
1.3 something.
Into 10 to the power? Nothing. Let's try to do it. Okay. So they are asking to find the displacement amplitude, na? And displacement amplitude, that's A. Acha, what is the information given to us? You are given pressure amplitude K and X, and that phase, don't worry about that. Ye pressure amplitude or displacement amplitude mein, is there any relation? There is, na? Delta PM is BAK. So I think I already have my K, I already have my delta PM, that's 12. How to find this B? So for that B, you have to relate this. B is equal to, V, velocity of a wave is under root B by rho. And then what is B? That's rho V square. So I can, instead of B, I will write rho V square. And what is V? That's the velocity of the wave. That's omega by K. Yes or no? And then I think ye K kata. So then what do you get? You will get something like rho A omega square divided by K. That's delta PM. This is another formula that you can remember if you want. Okay. But anyways, what is A then? That's delta P max into K divided by rho omega square. So, अब substitute and get the answer. What is delta P max? 12. What is K? 8.18. Rho 1.29. Omega 2700 का स्क्वायर. करो कैलकुलेशन, टेल मी. कर लोगे ना या फिर खुद करके बताओ? एनीबडी हु डज नॉट नो डिविजन? करो, इतना सिंपल चीज़ तो है। डिड यू अंडरस्टैंड द प्रोसेस? चलो आंसर निकालो, बोलो।
particular formula for displacement amplitude.
मतलब देखो, द थिंग दैट यू हैड टू अंडरस्टैंड वाज डिस्प्लेसमेंट एम्पलीट्यूड को प्रेशर एम्पलीट्यूड के साथ रिलेट करो, और उसका मैंने फॉर्मूला दिया हुआ है जो BA के।
Pressure amplitude का भी displacement
डिस्प्लेसमेंट एम्पलीट्यूड A होता है बेटे। हाँ, उसी का नाम ही A है, ठीक है। चलो आंसर बताओ जल्दी जल्दी। कितना? 9 इंटू नहीं आएगा, ज़्यादा अप्रॉक्सीमेट कर लिया बेटा। -4 भी थोड़ा रॉन्ग है। एनीबडी एल्स? मैं एग्जैक्ट आंसर नहीं निकालने वाला, मैं थोड़ा अप्रॉक्सीमेट निकालूंगा मैं भी। तो कोई एग्जैक्ट निकालना चाहता है तो कर सकता है। आया आंसर? क्या करूं, मैं कर दूं? The lecture is still 120 ना? 110 120 तक ही है ना? हाँ, from 11:50 it's still 120. डिवाइड करो बेटा, डिवाइड। वन पॉइंट इंटू चल जाएगा। इट्स नॉट द बेस्ट ऑफ द आंसर्स। 1.04 इज करेक्ट, बट ठीक है, चलेगा। 10⁻⁻5। एनीबडी एल्स विद एनी आंसर्स? करेक्ट है। 0.104 10⁻⁻4 इज एक्चुअली एग्जैक्ट। इसका आंसर आ रहा है 1.04 इंटू 10⁻⁻5। क्या है? न्यूटन ना? अच्छा, मीटर्स होता है, ठीक, चल जाएगा। मैं भी कर देता हूँ फॉर दोज हु आर स्ट्रगलिंग। माई आंसर विल नॉट बी सो एग्जैक्ट, ओके? मैं बहुत अप्रॉक्सीमेशन करके करूँगा। तो पहली बात तो ये 8.18 और 1.29 को वो डेसिमल्स कट जाएंगे, देन ये हो जाएगा 818 डिवाइडेड बाय 129 को 130 ले लिया, और ये 27 का स्क्वायर ना, 10⁻2 का स्क्वायर ऊपर जाएगा, 10⁻⁻4 हो गया। इज इट ओके? अब देखो, ये 3 के टेबल से ज़्यादा है, 3 4 3 9 ठीक है। अब 27 1 27, 27 30 8 10, बट 8 20 मान लूँगा, ये 8 10 है तो ये 30 अप्रॉक्सीमेटली चल गया, ठीक है। फिर ये हाँ 0 0 भी कटा ना, ये 0 0 गया, तो अब बचा कितना, ये हो जाएगा, ये 4 तो है ना, ये हो जाएगा 4, डोंट टॉक, 13 9 27, सही किया ना, देखो ज़रा। अच्छा ये 1, तो ये 3 1 3 3 और ये 10 पावर -4 हुआ, तो ये हो जाएगा 4 डिवाइडेड बाई 39 10 पावर -4, इसको अप्रॉक्सीमेटली 4 डिवाइड बाई 40 ले लेते हैं। तो 4 डिवाइड बाई 40 बताओ कितना होता है, तो ये हो जाएगा 0.1 इंटू 10 पावर -4, और ये लगभग सही चल रहा है, 1 इंटू 10 पावर -5 आ गया आंसर। आई टुक 2 अप्रॉक्सीमेशन, एक 39 को 40 ले लिया और एक 18 को 820 810, ठीक है। ऐसे करो, ये सब करना पड़ेगा वरना लाइफ बहुत मुश्किल है, ठीक है। आई एम नॉट टीचिंग एनीथिंग मोर देन दिस फॉर टुडे, सो यू कैन टेक द लीव।